Hello everyone. Today we will present a case study on the F-35 program focusing on job costing and project profitability. The F-35 is a highly complex defense project and analyzing its financial side offers key lessons in cost accounting, especially in cost tracing versus cost allocating, job costing for custom built products, and process costing for large scale productions. Here's a quick summary of what we will cover. We'll introduce the F-35 program, highlight the key challenges, explore costing and pricing, discuss unitary cost, dive into job costing, look at price evolution, and finish with success factors and recommendation. Let's get started.
The Lockheed Martin F-35 Lightning II is a fifth-generation multi-role stealth fighter aircraft developed to perform both air superiority and ground attack missions. Designed for development by the US Air Force, Navy, and Marine Corps, as well as allied nations, it features advanced avionics, stealth capabilities, and networked warfare features. Despite its technological promise, the F-35 has faced persistent scrutiny due to development delays, cost overruns, and maintenance challenges, making it a landmark case for analyzing cost management and pricing strategy in complex defense programs. The program was greatly delayed and over budget due to the fact that the aircraft was being developed, tested, and manufactured at the same time. This led to multiple rework, especially software integration and increased indirect costs. The program was over budget by more than $160 billion and delayed by 7 years. Ongoing software integration issues led to certification delays and increased investment in test facilities. These challenges highlight the need for efficient cost control, pragmatic scheduling, and delicate design from production stages in intricate defense projects.
The role of costing and pricing in the F-35 program. Managing costs was critical for the F-35's success. With a total acquisition cost of over $400 billion and a life cycle cost expected to reach 1.5 trillion, Lockheed Martin couldn't just add a simple markup to expenses. Instead, they had to design a pricing strategy based on what the market could afford. The F-35A initially cost over $100 million per plane. By improving internal efficiency and aggressively cutting costs, Lockheed Martin reduced the price to around $77 million. This price drop made it affordable for more countries, helping the program survive financially and expand internationally.
Unitary cost is the manufacturing cost of a single unit, and is especially important when it comes to complex, expensive projects such as the F-35. This is the total cost of a single unit determines the price of the unit then sold for. If unitary costs are too high, so will be the price of F-35s, decreasing sales volumes, making it difficult to pay back huge fixed costs of the project, such as R&D. The production of F-35s was almost stopped in its early stages due to this issue, and so Lockheed Martin made their production and logistics more efficient by, for example, streamlining their suppliers and through bulk buying standard parts, in turn reducing unitary costs.
Job costing and its application to the F-35. On the right, we can see a diagram showing the key elements of the F-35's job costing system. Indirect cost, cost allocation basis like machine hours, and direct costs such as materials and labor. Job costing was crucial to track exactly where the money was going during the F-35's complex development. It separated direct costs like titanium and assembly work from indirect costs like system testing and rework. Software integration failures alone cost over $300 million in delay and recertification costs. Thanks to job costing, Lockheed Martin identified these problems early and justified investments in automated testing and simulation tools, helping reduce rework, avoid scheduled runs, and save money over time.
When it comes to their pricing strategy, Lockheed Martin actually employed cost-plus pricing strategy, which was successful in the beginning but became unsustainable as costs rose up. The company therefore decided to shift to a target pricing approach where it first considered how much governments were willing to pay for their products, and from there determined the cost they should have to ensure their products can be sold at the price desired by buyers while profits still made. To implement this, Lockheed Martin reduced costs associated to logistics, supplier management, and procurement, and at the same time used value engineering to minimize the complexity of F-35 designs and the test duration of aircrafts.
Despite all the challenges, the F-35 program achieved important successes, and much of that was thanks to smart cost control. First, the aircraft was designed with modular upgrades in mind, so future improvement could happen without needing a full redesign. This approach helped manage lifecycle costs much better, and it perfectly aligned with value engineering strategies. Secondly, international partnership made a real difference because they allowed development costs to be shared and production volume to grow. As a result, unit cost came down over time, helping the program hit its pricing goals. And finally, Lockheed Martin's shift towards target pricing along with better cost tracking gave the company the ability to adapt to buyer demands much more effectively. Altogether, these moves show how continuous improvement and strong job costing practices lead to better results, smarter, and more efficient programs. Managing future defense programs like the F-35 requires strong cost accounting from the start because early mistakes in design, testing, and production are expensive and hard to fix. That's why setting up normal costing early helps estimate cost correctly and track performance as the work progresses. Development should use target pricing and value engineering to meet market needs and stay within the budget even before production begins. Tracking direct and indirect costs at every level is essential because it shows exactly where overruns happen. Finally, lifecycle costs like maintenance and upgrades must be included early to avoid surprises later. If these practices are followed, programs will be more transparent, efficient, and sustainable over time.